Hello everyone. So today we will discuss chapter number 9 of ethical hacking course. Chapter is about embedded operating system. So in this chapter we have mainly two agenda items. Firstly, we will discuss the definition of embedded system, definition of embedded systems, and then we will also discuss the embedded operating system and types of embedded operating system. Secondly, we will discuss the examples or types of embedded systems and their vulnerabilities. So these are the two things that we're going to talk about. Typically, in embed, when we do the ethical hacking or penetration testing, we sometimes we ignore these embedded systems. Embedded systems are basically like, for example, we have router, switch, firewall. These are embedded. These are basically embedded examples of embedded systems. Even your car key fob as well. Like for example, if you have a access control based key of your car, it also use a embedded operating system. For example, your remote control, TV remote control, anything which has a hardware, it must have an operating system. And if there is an operating system, that device can be hacked. Okay, so we sometimes, for ethical hackers, they ignore this particular part, the small embedded devices operating system, like sensors, RFID sensors, they do have operating system. So let's start with the definition of embedded system, types of embedded operating system, and then we will see their problems. So embedded system is any system, or you can say computer, which is designed, any system which is designed to perform or to perform a specific task is called embedded system. Embedded system is just like a computer. So that's why we sometimes call embedded system as system on chip, because it takes input from user. Based on user input, it will process the input or the data, and then it will give you a specific output. So you can call it a computer as well. You can get this done from a specific chip as well, electronic chip. It could be a sensor which can monitor maybe temperature and process it and forward it towards the servers or web servers, or for example, maybe directly to the user as well. So any system which is designed to perform a specific task is called embedded system. Embedded systems are also called SoC, system on chip. And system on chip, and they typically use operating system called RTOS, real-time operating system. That's basically what typically embedded devices they use. Embedded devices, as I mentioned earlier, it could be sensors, it could be chips, electronic chip, it could be, we typically call routers, switches, firewall also as embedded systems. A real-time operating system can be further classified into two types. One is the open source like Linux, and the second type is basically which is patent, or you can say licensed. You need to actually buy a license, for example, Microsoft or Microsoft Windows. Okay, Microsoft. So these are the two, just like the other operating system. Operating system could be open source, open for public, or it could be licensed, patent, where you have to purchase a corporate license for all of your devices. Let's start with the first one, licensed, which is Microsoft is the leading company who actually who designed this embedded operating system, just like the desktop operating system. But these embedded operating system are not for individuals. These operating systems for companies who actually manufacture these kind of sensors. Okay, so they actually, for each of these particular sensor, this small chip or small device, Microsoft, they do have an operating system. The latest operating system of these devices is Windows 10 IoT's variant. Windows 10 IoT's variant, and it provides full API, Windows API, application programming interface, where you can individually encode all these sensors. The previous variants of Microsoft was Windows CE, which is basically called embedded computer. Uh, Windows CE, it's basically has been replaced with Windows 10 IoT now, but still some of the organization they still use Windows CE. The best thing about Windows CE is it's basically open source. So source code is freely available. Freely available. So people they actually they use this CU because CE Windows CE embedded computer Windows because source code is freely available. You can customize it and you can also use the exactly as it is as well. Other than that, the filing system which come with the Windows 10, it's basically NTFS, which is basically new technology file system. It is more secure and plus more manageable as compared to Windows CE, which typically it uses FAT, file allocation table. The problem with file allocation table is it doesn't allow you to create a access control list. No ACL support. No ACL support, so basically it is less secure as compared to NTFS. That's basically one of the problem of Windows CE. So you have to actually create maybe your own filing systems. Otherwise, what's the problem is that attacker they can get the unauthorized access to these resources running Windows CE. That's basically the by default problem. But still it use FAT, and FAT typically doesn't support access control list, like who can access this particular sensor and stuff like that. So you cannot actually host that access control list on each sensor. That's the only problem. So Cisco devices typically use QNX softwares, QNX servers. This is QNX software. They use QNX software. Most of the printers, like HP printer especially, they typically use Green Hill software. All these software, these operating systems are basically embedded operating system, specifically designed for embedded devices, having no GUI, nothing like that, and they support a network control as well. Second is the Linux embedded operating system. Just like the licensed operating system, we do have the open source Linux-based embedded operating system, and one of them is called monolithic operating system, which is, of course, as I mentioned, it is open source. So you can customize it as well. It uses Mac. By default, it uses Mac mandatory access control. So mandatory access control is basically mandatory access control system. Mandatory access control system basically defines or enforces the rules, like who can access the sensor, who cannot access. So sensor has a capability of controlling the access. So mandatory access control, if you want to define it, it basically enforces the rules of access control between the process and user. Process, like you can say sensor and user. Okay, it controls the access. The only problem with Linux-based embedded operating system is Rootkit. That's the only problem which allows the attacker to gain control of the sensor. In fact, especially the Rootkit 5. That's the only problem. And the problem with these Rootkit are they basically infect the firmware part of the device, or you can say of your embedded device. In fact, okay, firmware part mean whenever they actually get into the operating system files, and typically on these sensors they just have mainly operating system file and a functionality. Like this is a sensor, for example, it has operating system files plus this is basically the sensor functionality like application. So Rootkit basically become a part of these operating system file, and they try to infect that, become a part of it, and they might allow the attacker to gain control of the sensor or that embedded device. It could be a router as well. So they become a part of the operating system file, and does not affect the functionality. But of course, through the operating system, you can control the functionalities. Other than that, these rootkits, some of the rootkits are basically BIOS based. These are BIOS based rootkit, which can be installed in flash memory of the device, and allows the attackers to access device on later dates as well. So attacker can actually access that device later on as well. There are different types of rootkits which are very common nowadays. Uh, Next is the vulnerabilities of embedded operating system. So this is just an introduction of embedded operating system. We discussed the license like Microsoft Windows, one of the key player, QNX, Greenhill. These are some other companies who actually design embedded operating system for Cisco printers and scanners and all that devices. Linux free variant is also available, which you can modify. By default, it comes with Mac mandatory access control model, which can be changed. You can put your own access control model to control the access of sensors. Vulnerabilities of embedded operating system. One of the biggest problem is cloning. People can make a clone of your devices. Okay, clone is also possible. Like you might heard of card skimming, like ATM debit card or credit card skimming, because it does have a chip. If it does have a chip, and that chip has that particular chip controls the or holds the data of the user, so people can actually make a clone, and card skimming is still possible. And if somebody make a skim, and if they use, for example, Linux operating system or maybe Windows CE, so it makes them much easier to make a clone, because you have all the operating system, and if you already have the data, you can make a clone. Second problem is, if these particular sensors, let's say if these sensors, they respond to a SQL server. So as you know, SQL server, they have a typical vulnerability, which is called null SA password. So null SA password is basically null system admin password. By default on SQL server, if you it does come with a SA account, system admin account, with having no password. So there is no password. So system administrator, again, if we keep it, we use it by default. So of course, that's one of the problem. But of course, it's not that critical issue, but still it is a problem of SQL servers. Okay. The third is rootkit, which we already talked about. Rootkits is also a problem of embedded operating systems, specifically for the Linux. These embedded operating systems, just for the better manageability, these embedded operating systems are networked. What does it mean? For example, this is basically the corporate company server who controls all these sensors. So let's say I have laid down my sensors in a field, which basically monitor temperature, traffic pattern, or stuff like that, running on some embedded software. So what I do is, it is very hard to individually communicate with these sensors. So what we do is, although they do have an ID, they do have an operating system as well, all these sensors. So these ID operating system, I mean, these sensors, basically, they communicate to the server through internet. So basically, they're connected with the internet. They dump the data on internet, and through internet, they connect with the server. So what we do is, we typically make the WLAN, wireless local area network. Okay, like it's a wireless local area network plus wide area network. We made a wide area network and try to make a VPN sometime. So we can securely communicate with these sensors, and nobody else can communicate with these particular sensors. So the best, why it is a network, because we can better manage these devices. And if there is any web server, like any web server running on these particular sensors, it is basically a vulnerability. So web server running on embedded operating system is a vulnerability, and attacker can actually take control of that device as well. So basically, these embedded operating system, they do have web services, like, because these web services allow them to interact or communicate over internet. But we do protect them with some kind of security firewall. The second thing about embedded operating system, embedded devices is just to protect these particular sensors from unauthorized access. We use a filing system called CIFS, Common Internet File System. If you remember, this is basically the file system that we already discussed in the previous chapter. This system is, of course, much secure as compared to file sharing thing. If you remember the file sharing, NetBIOS and file sharing, it is basically much secure than that. And it avoids the unauthorized access as well. Like this web service is, even though if web service is running, if you use this file system, it will protect the unauthorized access. CIFS uses two type of security. One is called user level security. Second is called share level security. User level security mean if anybody wants to access this particular sensor, so user have a username plus password in order to access these sensors. In share level, there's no security, no password is required. Anybody can actually access the sensors or can communicate. But typically, user level mode is enabled in order to access or in order to actually communicate with these particular sensors. There are some problems with these small sensors or these IoTs, Internet of Things. One is they're difficult to patch. Like sometimes there is a possibility cost of patch over is more as compared to the sensor itself. So cost is sometimes a biggest hurdle. Second is the buffer overflow attack. Especially the application which are designed in C or C++. Now, for example, if this is a sensor, if anybody identified there is a sensor, found the IP address, of course, it is much easier to launch a buffer overflow attack, or you can say a DOS attack. Why? Because they don't have enough memory to communicate, because these are very small sensors having a very small memory on chip. Next is some network devices. One of the network device, as you can say, for example, router or switch. Now just imagine if your router gets compromised. So the attacker can control the access of your local area network. Attacker has full access to your local area network devices, plus attacker can sniff the data as well. Like attacker has full authority now. Some other network devices are like MFDs, multi-function devices, multi-functionality or function devices. Multi-function devices are, for example, printer. Printers can be used as a scanner. They can be used as a fax machine as well, or you can also send email. It also has email server running on it. So of course, if anybody hack, or because of course the printers, they use operating system. If anybody gets the operating system, they can use printer, scanner, fax, email. They can do anything because it does use SMTP protocol. It does use some other TCP/IP functions as well. Number 3 is another technology which is called SCADA. I believe everybody heard of SCADA technology. Supervisory control and data acquisition. Supervisory control and data acquisition, SCADA systems, they are typically used to control and manage or monitor the devices remotely. Okay, for example, use to control, manage, monitor the devices, or you can say systems, remotely. For example, this is your power grid station, and it is, let's say, a hydraulic powered grid station which produce electricity. So we can actually, there are basically some sensors which are basically communicating, and through which they are basically controlling over this, and we can actually monitor and control over through remotely by using this SCADA system. So what happens actually, these sensors or these SCADA devices, they will control this information, and then through internet you can actually communicate, or you can control over these particular devices. Now the only problem is, if anybody, because it's they're sending the data, or they're communicating over internet. So if a hacker will also try to access these particular SCADA system, they can also take control of your electric grid station, or for example your manufacturing unit, stuff like that. So in order to protect that SCADA system, they use a special kind of firewall, and that firewall is called air gap, which separates the SCADA devices from internet. Like everything basically filter out when it gets to the SCADA system. So that's basically kind of a firewall which separates SCADA system from internet. Other than that, some other networking devices are, for example, number 4, cell phones. Cell phones are also basically something which people, they actually use cell phones for, I mean, that's because these also use a mobile operating system. Mobile operating system similar to your embedded operating system. Mobile operating systems are like Android. For example, we have Apple, what Apple use, I guess it is iOS. For example, BlackBerry World, something like that. All these are mobile operating system similar to embedded operating system, but they have a GUI plus API, unlike the embedded operating system, which doesn't have a GUI. The biggest problem of cell phones are sniffing, and the second problem is nowadays some Java based viruses, malwares, attackers, they have started creating these Java based viruses, Java programming based viruses, which can target these mobile operating systems. So that's it about our embedded operating system. Just we have discussed the definition of embedded system. We discussed the examples of embedded system, and like we discussed sensors, we discussed network devices, and we have also discussed some vulnerabilities. So we will quickly discuss that in our class, and if you will have any questions, please do reach me out. Thank you.